November 12, 1944. Tromsø, northern Norway. In the freezing Arctic air, the battleship Tirpitz lay motionless inside the fjord, a steel fortress hidden between mountains and sea. For 3 years, the British had tried almost everything to destroy her. Mini-submarines, carrier airstrikes, armor-piercing bombs. None of it had worked. The Germans believed the ship was still safe. Her armor was still intact. Her torpedo nets still surrounded the hull. Smoke generators on the cliffs were already filling the fjord with white fog. But on that morning, something had changed. The British were no longer trying to break Tirpitz's armor. They were aiming at what held the ship in place, and within 11 minutes, the most powerful battleship in Europe would roll over and die. Not because she had grown weaker, but because the rules of war had changed. November 1944, northern Norway. The Arctic sky hung low and pale over the fjords. Snow clung to the mountains, and the sea below lay dark and silent, like a sheet of cold metal stretching between the cliffs. In the center of that frozen landscape rested a warship unlike any other in Europe. Tirpitz, more than 250 meters long and weighing over 52,000 tons, fully loaded, she was the largest battleship ever built by a European navy during the Second World War. Her main armament consisted of 8 massive 380-millimeter guns mounted in 4 twin turrets. Each shell weighed close to 800 kilograms and could travel more than 30 kilometers before striking its target. At that distance, a single hit could cripple or destroy a cruiser. But what truly frightened the Allies was not only her firepower, it was her survivability. Tirpitz was built as part of the Bismarck class, a design philosophy that prioritized endurance in battle above almost everything else. Her main armor belt reached over 300 millimeters of hardened steel. Her armored deck ranged from 100 to 120 millimeters thick. Inside that steel shell lay the armored citadel protecting engines, boilers, and ammunition magazines. German engineers believed that if the outer structure of the ship were damaged, the citadel would still keep the heart of the battleship alive. And for years it seemed they were right. Yet Tirpitz fought very few battles. Unlike her sister ship Bismarck, which was hunted down in the Atlantic in 1941, Tirpitz spent most of the war anchored deep inside the fjords of occupied Norway. From 1942 onward, she operated primarily from hidden anchorages such as Alta-fjord and Kofjord, places where steep mountains rose straight out of the sea. These fjords were natural fortresses. Cliffs hundreds of meters high surrounded narrow channels of water. Any aircraft attempting to attack had to fly through a maze of rock walls and sudden wind currents. For pilots approaching at low altitude, the fjords could feel like flying into a canyon with no room to maneuver, and geography was only the first layer of defense. Around Tirpitz's hull, the Germans installed heavy anti-torpedo nets anchored to the seabed with chains and steel cables. Any torpedo that entered the anchorage would likely become tangled in the mesh long before reaching the ship. On the cliffs above the fjord, specialized units operated smoke generators designed to conceal the battleship within minutes. The system used chlorosulfonic acid to produce thick white smoke. Once activated, the generators could fill an entire fjord with artificial fog. To an attacking bomber crew, the ship would simply vanish. If you could not see the target, you could not hit it. Life aboard Tirpitz settled into a strange routine. The ship had been built for great naval battles, for clashes between fleets and long-range gunnery duels across open water. Instead, her crew spent most of their time waiting in the cold silence of the fjords. Days passed with little activity. Crews performed maintenance on the engines, trained with anti-aircraft guns, and inspected the massive machinery that filled the ship's interior. Every few weeks, alarms would sound. Enemy aircraft had been detected. Men would rush to their stations. Anti-aircraft guns would swing toward the sky. Smoke generators on the cliffs would begin pumping white clouds into the air. Sometimes the aircraft turned back before reaching the fjord. Sometimes they attacked but failed to see the ship through the smoke. When the danger passed, the alarms would fade and the routine would begin again. Over time, this pattern created a powerful belief among the crew. Tirpitz was almost untouchable. The fjords protected her. The nets protected her. The smoke protected her. And even if a bomb did hit the ship, the armor would hold. After all, that was the entire purpose of a battleship. But far away in London, One man saw Tirpitz very differently, Winston Churchill. To him, Tirpitz was not just another German warship. He called her the Beast. Not because she had sunk dozens of ships. In fact, Tirpitz rarely fired her guns in anger. The real problem was strategic. Naval planners used a phrase to describe ships like Tirpitz, a fleet in being. The concept was simple. A powerful warship did not have to fight battles in order to influence the war. It only needed to exist in the right place. As long as Tirpitz remained in Norwegian waters, the Royal Navy had to assume that she might sail at any moment. And if she sailed at the wrong time, the consequences could be catastrophic. The greatest concerns centered on the Arctic convoys. These convoys carried weapons, vehicles, and supplies from Britain and the United States to the Soviet Union. They traveled north around Norway before reaching ports such as Murmansk and Arkhangelsk. The route was already one of the most dangerous in the war. Arctic storms battered the ships with freezing winds and towering waves. Ice formed on decks and superstructures, sometimes threatening to capsize smaller vessels. German submarines hunted beneath the surface. Aircraft from bases in Norway attacked from above. But the most terrifying possibility was that Tirpitz might appear among the convoy ships. A battleship armed with 8 380mm guns could destroy lightly defended merchant vessels with terrifying speed. One appearance by Tirpitz could wipe out an entire convoy, so the Royal Navy could never allow that to happen. Because of Tirpitz, Britain had to keep powerful warships constantly stationed in the north. Battleships such as HMS King George V, HMS Anson, and HMS Duke of York were often held at readiness in Scapa Flow, waiting for any sign that Tirpitz had left her fjord. Cruisers, destroyers, and sometimes aircraft carriers joined them. These ships could have been used in the Atlantic, the Mediterranean, or the Pacific. Instead, they waited, sometimes for months, waiting for a ship that rarely moved. The psychological impact was enormous. Every Arctic convoy commander knew that somewhere along the Norwegian coast lurked a battleship capable of destroying his entire formation. Even if Tirpitz never appeared, the threat shaped every decision. Convoys required heavier escorts. Routes had to be adjusted. Timing became critical. A single German ship forced the British Navy to commit enormous resources simply to guard against the possibility of her attack. That was the power of a fleet in being. Churchill understood the situation clearly. In a memorandum to the Admiralty, he wrote words that would echo through the war. The destruction or crippling of the Tirpitz is the greatest event at sea at the present time. No other naval target mattered as much. Until Tirpitz was gone, the Royal Navy could not fully redeploy its strength. The Beast had to die. But killing her proved far more difficult than anyone expected. Over the next 3 years, the British would attempt attack after attack. Carrier-borne aircraft, miniature submarines, massive airstrikes. Some caused severe damage. Yet every time Tirpitz survived. And with each survival, the legend of her invincibility grew stronger. Among the German crew, confidence hardened into certainty. Their ship might be scarred, but she could not be sunk. What they did not realize was that somewhere in Britain, engineers and planners were beginning to rethink the entire problem. For years, the Allies had tried to defeat Tirpitz by the traditional rules of naval warfare. Break the armor, destroy the ship. But every failed attack suggested the same conclusion. The armor was not the real weakness. The real weakness lay somewhere else, somewhere beneath the steel. By the summer of 1943, the British Admiralty faced a problem that seemed almost impossible to solve. Every conventional method of destroying Tirpitz had failed. Carrier aircraft had attacked and been driven away by anti-aircraft fire and smoke screens. Surface ships could not approach the fjords without exposing themselves to submarines, mines, and air attack. Even long-range bombers struggled to reach the narrow anchorages where the battleship hid. Each attempt revealed the same reality. Tirpitz was protected not only by armor and guns, but by geography. The fjords of northern Norway had become part of the ship's defense system. Steep mountains forced aircraft into predictable approach paths. Narrow waters limited torpedo attacks. German radar stations on the surrounding cliffs could detect incoming aircraft long before they reached the target. Every element worked together: terrain, technology, steel. For the Royal Navy, it was like trying to destroy a fortress built inside a mountain. Eventually, someone proposed a solution that sounded almost absurd. If Tirpitz could not be attacked from above or from the surface, then perhaps she could be attacked from below. The concept led to one of the most daring operations of the war. Operation Source. The weapon chosen for the mission was something entirely new, the X-craft. These were miniature submarines barely 15 meters long and just over 2 meters in diameter. Each vessel carried a crew of 4 men and 2 massive side charges filled with explosives. Inside, conditions were claustrophobic, even by submarine standards. The crew could not stand upright. Space was so limited that sleeping meant curling up beside machinery and batteries. The smell of diesel fuel, lubricating oil, and human sweat filled the cramped compartment. Air was recycled through chemical scrubbers designed to remove carbon dioxide, but the system was primitive. After long periods underwater, the atmosphere inside the submarine became thick and difficult to breathe. Yet the mission demanded that these crews remain submerged for hours, sometimes days. Their objective was simple in theory. Reach Tirpitz, place the explosive charges beneath her hull, escape before the timers detonated. In practice, every stage of the mission bordered on impossible. The X-craft could not travel the entire distance from Scotland to northern Norway on their own. Their small engines and limited fuel capacity made such a journey unrealistic. Instead, the submarines would be towed across the North Sea by larger fleet submarines. The trip covered nearly 1,000 miles of open ocean, often through violent storms. If the tow line snapped or the miniature submarine flooded, the crew inside had almost no chance of survival. Several X-craft were lost during the journey alone. One disappeared entirely when its tow cable broke in rough seas. Another suffered mechanical failure and had to be scuttled by its crew before reaching the target area. By the time the operation approached the Norwegian coast, only a handful of the tiny submarines remained. Among them was X-6, commanded by Lieutenant Donald Cameron, a 23-year-old officer who had volunteered for the mission. Cameron's submarine faced problems even before reaching the fjord. Equipment failures began to accumulate. The periscope had been damaged by heavy seas. The gyro compass began giving unreliable readings. The depth gauge fluctuated unpredictably. Navigation became an exercise in guesswork. Inside enemy waters, Cameron and his crew relied on dead reckoning and occasional glimpses through a cracked periscope lens. The closer they came to Tirpitz, the more dangerous the situation became. German defenses surrounded the anchorage. Anti-submarine nets blocked the narrow channels. Patrol boats searched the waters above. Searchlights swept across the fjord at night. Yet somehow Cameron's submarine slipped through the outer defenses. Early on the morning of September 22, 1943, Cameron felt the hull of his submarine scrape against something solid. He cautiously raised the damaged periscope. What he saw surprised him. Above the waterline, only a short distance away, towered the immense hull of Tirpitz. The miniature submarine had penetrated all the defensive barriers and arrived directly beneath the German battleship. At that moment, the engine failed. The submarine surfaced unintentionally beside the warship. German sailors immediately spotted the strange vessel. Rifles opened fire. Hand grenades splashed into the water. Cameron understood instantly that escape was no longer possible, but the mission could still succeed. He ordered the submarine to dive one final time. X-6 settled onto the seabed directly beneath one of Tirpitz's massive gun turrets. There, Cameron and his crew released their explosive charges. Each charge contained nearly 2 tons of Amatol. Timers were set. After that, the crew had no reason to remain. They scuttled the submarine and surrendered to the German sailors waiting above. For nearly an hour, Cameron and his men sat on the deck of Tirpitz as prisoners. German officers demanded to know what they had done. Cameron said nothing. He simply watched his wristwatch. At 8:12 a.m., the charges detonated. The explosion erupted beneath the hull with tremendous force. More than 50,000 tons of steel lifted briefly out of the water before slamming back down. Men across the ship were thrown off their feet. Lights flickered and failed. Massive gun turrets weighing hundreds of tons shifted on their bearings. The blast ruptured seams in the hull and flooded several compartments. For a moment it seemed possible that Tirpitz might finally sink, but the ship's design worked exactly as intended. The double hull absorbed much of the damage. Internal bulkheads slowed the flooding. Damage control teams rushed into the affected compartments and began sealing leaks. Cold seawater filled the lower decks as sailors struggled waist-deep in darkness to reinforce the damaged structure. Hours passed. Eventually, the flooding stabilized. Tirpitz had survived. The attack was considered a remarkable act of bravery. Donald Cameron received the Victoria Cross, Britain's highest military decoration. But strategically, the result was disappointing. Despite the enormous explosion beneath her hull, Tirpitz remained afloat. German repair teams worked relentlessly in the following months. Sections of damaged plating were replaced, machinery was restored, electrical systems were repaired. By early 1944, the battleship was operational once again. For the German crew, the conclusion seemed obvious. If 2 tons of explosives placed directly beneath the hull could not sink the ship, what could? Confidence in Tirpitz grew stronger than ever. The armor had held. The structure had survived. The beast was still alive. But for British planners, Operation Source delivered a different lesson. The attack had come closer to success than any previous attempt, and it revealed something important. Even if the ship's armor remained intact, powerful explosions could still disrupt its internal systems. The key was not necessarily penetrating the armor. The key was delivering enough energy in the right place. That realization would shape every future attempt to destroy Tirpitz. In April 1944, the Royal Navy launched another major operation. This time, the attack would come from the air. The plan was called Operation Tungsten. 2 fleet carriers and several escort carriers launched a strike force of more than 40 dive bombers, supported by dozens of fighter aircraft. The attack began at dawn. For once, the German smoke generators reacted too slowly. The fjord remained clear long enough for the British aircraft to see their target. Barracuda dive bombers plunged toward the battleship and released their armor-piercing bombs. Within seconds, multiple explosions ripped across the deck. From the air, it looked like a devastating success. The upper structure of the ship was torn apart. Fires burned across the deck. Anti-aircraft crews were killed at their guns. More than 100 German sailors died in the attack. Yet when reconnaissance photographs were later examined, analysts noticed something astonishing. Tirpitz was still floating perfectly level. The bombs had struck the ship, but they had failed to penetrate the main armored deck. The reason came down to simple physics. The bombers had been forced to release their weapons from relatively low altitude because of cloud cover. Without sufficient height, the bombs could not accelerate to the velocity required to penetrate the thick steel armor. They destroyed radar systems, guns, and crew quarters, but the engines and ammunition magazines remained untouched. Once again, the beast had survived. After Tungsten, frustration within the British command grew. They had used submarines. They had used carrier aircraft. They had used armor-piercing bombs. Every method had inflicted damage. None had killed the ship. The question now was unavoidable. Perhaps Tirpitz could not be destroyed using traditional weapons at all. Perhaps the solution required something entirely different, something that ignored the armor completely. And that idea would soon arrive in the form of a new weapon designed by an engineer named Barnes Wallis. Wallis had already achieved fame for creating the bouncing bombs used in the Dam Busters raid. Now he proposed something even more radical. A bomb designed not merely to strike a target, but to shake the ground beneath it. By late 1944, the long hunt for Tirpitz had entered its final phase. 3 years of attacks had revealed one hard truth. Traditional methods were not enough. Carrier aircraft could damage the ship but not destroy her. Submarines could cripple systems but not break the armored citadel. The battleship's armor had been designed to survive exactly those kinds of attacks. If Tirpitz was going to die, the weapon that killed her would have to do something different. It would have to ignore the armor entirely. The solution came from British engineer Barnes Wallis. Wallis did not think about Tirpitz the way naval officers did. Admirals saw a warship. Wallis saw a physics problem. Instead of asking how to break through the steel armor of the ship, he asked a different question. What if the attack did not strike the armor at all? What if it struck the ground beneath the target? From that idea came a weapon known as the Tallboy bomb. Tallboy weighed 12,000 pounds, nearly 6 tons. It was over 6 meters long and shaped like an enormous steel dart. but its design was radically different from most bombs used during the war. Typical bombs exploded on contact with a target or shortly afterward. Tallboy was designed to do something else. It would fall from very high altitude and reach enormous speed, approaching the speed of sound. Instead of detonating immediately, it would bury itself deep into the ground before exploding. The explosion would then create what engineers called an earthquake effect. A massive shock wave would travel through soil, rock, or water, destabilizing the foundation of whatever stood above it. Buildings collapsed, bridges twisted apart, and in theory, a warship anchored in shallow water could be destroyed without ever penetrating its armor. For months, the Royal Air Force prepared to test this idea against Tirpitz, but delivering a weapon of that size required a very specific aircraft. Only the heavy Avro Lancaster bomber could carry a Tallboy. Even then, modifications were necessary. The bomb bay doors had to be redesigned. Defensive gun turrets were sometimes removed to reduce weight. Every detail was adjusted to allow the aircraft to lift the enormous weapon into the sky. The first Tallboy attack against Tirpitz came during Operation Paravane in September 1944. Lancaster bombers launched from bases in Britain and flew east to temporary airfields in the Soviet Union. From there, they attacked the battleship anchored in Tromsøfjord. Despite heavy smoke screens, one Tallboy struck near the bow. The explosion devastated the forward structure of the ship. Flooding spread through multiple compartments. Even more serious, the shock of the blast damaged the propeller shafts and internal machinery. Tirpitz could no longer sail effectively under her own power. The beast had finally been wounded in a way that repairs might never fully fix. German Naval Command now faced a difficult decision. Repairing the ship in northern Norway was extremely difficult. Moving her to Germany for full repairs was nearly impossible because Allied aircraft controlled much of the surrounding airspace. Instead, the decision was made to move Tirpitz south to Tromsø. There she would serve as a stationary coastal defense battery. Her massive guns could still threaten Allied forces if they attempted to invade Norway. To reduce the risk of capsizing, engineers even prepared a sandbank beneath the hull, intending that the ship would settle safely if damaged. In theory, this would make the battleship almost impossible to sink. In reality, it created the conditions that would soon destroy her. Early in the morning on November 12, 1944, 32 Lancaster bombers took off from bases in northern Scotland. Each carried a Tallboy bomb. The mission was called Operation Catechism. This time, there would be no staging in Russia. The target was now close enough to reach directly. Inside each aircraft, the crew understood the importance of the mission. For 3 years, Tirpitz had tied down enormous British naval resources. Destroying the battleship would finally remove that threat. At approximately 8 a.m., German radar stations detected the incoming formation. Alarms sounded across the fjord. Smoke generators on the surrounding cliffs were activated immediately. Thick white clouds began to rise across the water. The same defensive system that had saved the ship many times before was now being deployed again. But nature had introduced a small complication. The air that morning was completely still. There was almost no wind. Instead of spreading across the fjord, the smoke remained low over the water. The hull of the ship disappeared beneath the haze, but the tall masts and superstructure remained visible above the white cloud, and from high above, the bomb aimers could still see their target. German anti-aircraft batteries opened fire as the bombers approached. Heavy shells burst in black clouds around the formation. The turbulence shook the aircraft violently. Inside the Lancaster bombers, the bomb aimers prepared for the most dangerous moment of the mission, the bomb run. For nearly a minute before release, the aircraft had to fly perfectly straight. Any sudden maneuver would ruin the calculation of the bomb sight. Pilots could not dodge. They could not turn away. They had to hold course directly toward the target while anti-aircraft fire exploded around them. Some crews called this moment the dead man's run. When the first Tallboy was released, it began a long fall toward the fjord. Nearly 30 seconds passed before it struck. The bomb missed the ship itself by roughly 30 feet. But it struck something just as important, the sandbank beneath Tirpitz. The Tallboy penetrated deep into the sand before detonating. The explosion was enormous. The shock waves spread through the sand and water beneath the battleship. The ground supporting the ship suddenly lost its strength. In an instant, the sand turned into a semi-liquid slurry. The 50,000-ton battleship began to shift. Moments later, two more Tallboys struck the ship directly. These bombs carried tremendous kinetic energy after falling from high altitude. They punched through the armored deck that had resisted so many earlier attacks. The bombs buried themselves deep inside the hull before exploding. The detonation inside the ship was catastrophic. One of the massive gun turrets, weighing hundreds of tons, was blasted free from its mounting and thrown into the water beside the ship. Internal compartments collapsed. Bulkheads buckled. Machinery tore loose from its foundations. Inside Tirpitz, chaos erupted. Electrical systems failed almost immediately, plunging large sections of the ship into darkness. Water surged through ruptured compartments. The entire structure of the ship shuddered under the force of the blast. For the men inside, the experience felt like an earthquake inside a steel cage. Metal screamed as beams twisted. Pipes burst. Steam filled the air. At first, the list of the ship was slight, perhaps 10 degrees, then 20. Men on the deck felt the tilt growing beneath their feet. Loose equipment slid across the floor. Shells rolled from storage racks. When the list reached 40 degrees, movement across the deck became almost impossible. Crew members struggled to climb ladders that were now angled sharply toward the sea. Some attempted to reach escape hatches. Others were trapped inside flooded compartments. Water continued pouring into the damaged sections. With the sandbank beneath the hull now destabilized, the ship had no stable foundation. The center of gravity shifted further and further. Inside the hull, the roar of rushing water mixed with the grinding of metal. Men who had survived the explosions now faced another danger, drowning in the darkness of their own ship. At approximately 8:52 a.m., only 11 minutes after the first Tallboy struck, Tirpitz reached the critical angle. The massive battleship rolled completely over. The hull rotated slowly at first, then with unstoppable momentum. The enormous superstructure plunged beneath the surface. Moments later, the red-painted bottom of the ship rose above the water. The beast of the north had fallen. Inside the overturned hull, the situation became a nightmare. Hundreds of men were trapped in air pockets within the ship. Some attempted to find escape routes through twisted corridors. Others waited in darkness, hoping rescue teams would reach them before the oxygen ran out. From outside, rescuers later reported hearing faint tapping sounds from within the steel hull. Men were still alive inside, but the thickness of the armor made cutting through the metal painfully slow. For many of those trapped within the ship, help came too late. After years of surviving every attack thrown against her, Tirpitz had finally been destroyed, not because her armor had been broken, but because the weapon used against her had changed the rules entirely. The Tallboy did not simply attack the ship. It attacked the environment supporting the ship, and once that foundation failed, even the strongest battleship in Europe could not remain afloat. When the explosions faded and the smoke drifted away over Tromsøfjord, the destruction of Tirpitz became unmistakably clear. Where the most powerful battleship in Europe had once floated, only the overturned hull remained. The red anti-fouling paint of the ship's underside now faced the cold Arctic sky. For the German sailors watching from nearby shore batteries and patrol boats, the sight was almost unreal. For years, Tirpitz had been regarded as nearly indestructible. She had survived submarine attacks. She had endured carrier airstrikes. She had taken bomb hits that should have destroyed lesser ships. Yet now she lay capsized in shallow water, and the entire disaster had unfolded in just 11 minutes. Rescue efforts began almost immediately. German and Norwegian personnel rushed to the scene in small boats. Standing on the exposed hull, they could hear faint noises from inside the ship. Men were still alive within the overturned compartments. Trapped sailors began tapping against the metal walls, trying to signal their location. The rescuers brought cutting equipment and began burning through the steel plating using acetylene torches. But the same armor that had protected the ship from bombs now slowed every rescue attempt. Each hole required hours of work. And inside the sealed compartments, the trapped sailors had only a limited supply of air. One rescuer later recalled the most haunting part of the operation. At first, the tapping from inside the hull was constant. Groups of survivors were signaling their positions. Then gradually, the tapping began to fade. One by one, the sound stopped. Each silence meant that another air pocket had run out of oxygen. Another group of men had died waiting for rescue. In the end, 87 sailors were pulled alive from the wreck. For more than 900 others, the capsizing of Tirpitz became their grave. Some had been killed instantly in the explosions. Others had drowned as the ship rolled over. Many suffocated inside dark compartments where no one could reach them in time. The final fate of the ship's commanding officers remains uncertain. Reports suggest that several senior officers were on the bridge when the bomb struck. When Tirpitz rolled over, the bridge section was driven deep into the mud of the fjord floor. Anyone still inside that structure had little chance of survival. The command center of the battleship vanished beneath the water, along with the ship itself. For the German Navy, the loss of Tirpitz was more than the destruction of a single ship. It marked the end of Germany's last major surface threat in the northern seas. By late 1944, most of the Kriegsmarine's powerful warships had already been destroyed or trapped in port. Bismarck had been sunk years earlier in the Atlantic. Other heavy units were either damaged beyond repair or confined to defensive roles. Tirpitz had been the final symbol of German battleship power, and now it was gone. For the British, the sinking of Tirpitz brought immediate strategic relief. For years, the presence of the battleship in Norway had forced the Royal Navy to maintain powerful forces in northern waters. Battleships, cruisers, and aircraft carriers had been kept ready to intercept Tirpitz if she attempted to attack Allied convoys. These ships could not easily be redeployed to other theaters of war. Now that burden disappeared overnight. The Arctic convoys carrying supplies to the Soviet Union became significantly safer, and the Royal Navy could finally shift resources elsewhere. But the destruction of Tirpitz also carried a deeper meaning for naval warfare itself. For decades, the battleship had represented the ultimate expression of naval power. Countries competed to build ships with thicker armor, larger guns, and greater displacement. The logic was straightforward. A stronger ship could outfight and outlast its opponent. But the fate of Tirpitz demonstrated that this logic was beginning to fail. The weapon that destroyed the battleship was not another battleship. It was not a naval gun. It was not even a torpedo. Instead, the decisive weapon was a precision aerial bomb, guided by careful engineering and delivered by long-range aircraft. The Tallboy bomb did not rely solely on brute explosive power. Its effectiveness came from a combination of physics, design, and accuracy. By penetrating deep into the ground or the structure of a target before detonating, it generated shock waves capable of destroying even heavily armored structures. This approach bypassed the traditional contest between armor and firepower that had defined battleship design for decades. In this sense, Tirpitz represented the end of an era. She was built according to the principles of early 20th century naval warfare: heavy armor, massive guns, immense size. These characteristics had once defined the most powerful warships in the world. But by 1944, technology had begun to shift the balance. Aircraft had become capable of striking from distances that ships could not defend against. Bombs had become powerful enough to damage even the most heavily armored vessels. And increasingly, battles were decided by industrial production and engineering innovation, not just by the thickness of steel. The engineers who designed Tallboy understood something important. Instead of fighting armor directly, they changed the rules of the contest. Rather than asking how to penetrate a battleship's protection, they asked how to make that protection irrelevant. By attacking the environment around the ship, its foundation, the ground beneath it, and the structure supporting it, they created a weapon capable of defeating even the strongest warship. Once that shift occurred, the outcome for Tirpitz became almost inevitable. The story of Tirpitz also illustrates another lesson about warfare. Throughout the 3 years that the Allies attempted to destroy the battleship, failure was common. Carrier raids failed. Submarine attacks caused damage but not destruction. Conventional bombs inflicted casualties but could not penetrate the armored citadel. Each failure seemed to confirm that Tirpitz might truly be unsinkable. Yet every failed operation also provided information. Engineers studied the damage. Commanders analyzed what had worked and what had not. Gradually, those lessons accumulated, and eventually they produced a solution that succeeded. From a distance, the destruction of Tirpitz might appear sudden. 11 minutes of bombing, a massive ship rolling over in shallow water. But those 11 minutes were the result of 3 years of experimentation, adaptation, and persistence. Without the earlier failures, the final success might never have happened. In the decades that followed the war, historians often described Tirpitz as the lonely queen of the North. The name captured the strange nature of her career. She spent most of the war isolated in remote fjords, rarely firing her guns in battle. Yet her presence shaped naval strategy across an entire theater of war. Her mere existence forced the Allies to allocate enormous resources to counter the threat she posed. And when she finally fell, the strategic consequences were immediate. Today, the wreck of Tirpitz no longer rests intact in Tromsøfjord. After the war, large portions of the hull were salvaged and dismantled for scrap metal. But the memory of the ship remains one of the most dramatic stories of naval warfare during the Second World War. A warship designed to dominate the seas, a fortress of steel believed by many to be nearly indestructible, destroyed not by greater armor or larger guns, but by a shift in technology and strategy. In the end, the lesson of Tirpitz was simple. Strength alone is never enough in war. Even the most powerful machine can become vulnerable when the rules of the battlefield change. And on that cold morning in November 1944, the rules had already changed. The engineers had solved the problem. The bombers had delivered the weapon, and the beast of the North finally met its end beneath the quiet waters of a Norwegian fjord.